ADRENALINE Testbed is an intelligent optical network composed of a baseline switch optical network and a distributed control plane based on a generalized multi-protocol level switching architecture. The baseline switch optical network of ADRENALINE Testbed has two reconfigurable optical multiplexers and also two optical cross connectors that provides reconfigurable end-to-end light paths between any pair of source destination nodes. ADRENALINE Testbeds also deploys a total of 610 kilometers that are divided in 5 bidirectional links. The virtualization of the GMPLS control plane of ADRENALINE Testbed relies on the Linux kernel virtualization technology and the virtualization capabilities of the Intel CPUs. In this figure we can see the architecture of an optical connection controller that is not virtualized. It includes an RSMPT signal protocol that is responsible for the preservation of the wavelengths and also an OSPF routing protocol that is responsible for the dissemination of the topology and the optical resources. Apart from these two agents, there are also some other collaborative processes such as the link resource management that is in charge of the management of the local resources and also the hardware abstraction layer that is responsible of the communication with the optical hardware. The implementation of the GMPLS control plane of the ADRENALINE Testbed allows creating virtualized GMPLS connection controllers. That is, each virtual network, in our case, virtualized GMPLS-enabled WSON networks, has its own instance of the GMPLS control plane. Basically, it allows that each service provider can have a full control of all the functionalities of this virtualized network. So for example, it is possible to specify the internal routing policies and the network addressing schemes for each virtualized GMPLS-enabled baseline switch optical network. Once visualized the GMPLS control plane of ADRENALINE Testbed, as we can see here in the figure, the same physical machine can host a configurable number of virtualized GMPLS connection controllers. In this case, the data communications network channel is deployed over a shared physical infrastructure thanks to the KVM bridging, which allows to share the same network interface card, being able to provide connectivity between the virtualized GMPLS connection controllers. As we can see here in this figure, the baseline switch optical network of the ADRENALINE Testbed is composed of three main systems. The optical fiber switch, we also have at the upper stage of the reconfigurable optical multiplexer, and the last system are the tunable optical transceivers. The optical fiber switches are commercial and allows to work with virtualization, so it's possible to have different users working concurrently. As for the upper stage of the ROADMs, they have been developed and implemented by the CTTC. So in this case we have reprogrammed the controller cards in order to have multiple TCP connections that allows to have also concurrently different users. Finally, the tunable optical transponders are also commercial equipment, but they don't support virtualization since they handle serial protocols. So what we have done is to introduce a new element that is named Optical Transceiver System Controller that allows to work concurrently with several TCP connections.
The objective of this demo is to deploy two virtual scenarios over the physical resource of ADRENALINE Testbed. These two virtual scenarios have been created with the purpose to share the same physical link, using for each scenario a subset of different wavelengths. We observe with ADRENALINE Network Configurator and NetCom the physical scenario and the two virtual scenarios we want to deploy. NetCom includes a tool for monitoring which will allow us to make sure that virtual scenarios have correctly been deployed. Once the link has been established, we can start doing traffic reservations with ADRENALINE Network Traffic Generator, AdNetGen. Using AdNetGen, we ask for a connection between Lleida and Barcelona on the virtual scenario A. We will also request a connection between the same nodes on the virtual scenario B. We can see how a physical link is shared between nodes Lleida and Barcelona of the two different virtual scenarios. which was the purpose of this demo.